Hello everyone. Let's say you want to extract a specific range of bits from a 32-bit number. For example, take the hexadecimal number 0xabcd1234. Its 32-bit binary representation is. Now suppose we want to extract bits from position m equal to 4 to n equal to 7. The first step is to shift the number right by m positions. Why do we do this? Because we want the starting point, that is bit m, to move to the least significant bit position. All the lower bits that we don't need get discarded in this process. In this particular case, since we are considering m as 4, next we need to isolate only the required number of bits. This is where masking comes in. A mask is simply a binary number that has ones in positions we want to keep, zeros in position we want to discard. Now we calculate how many bits we need to extract. Since both ends are included, the width is n minus m plus 1, which is equal to 7 minus 4 plus 1, which is 4. So we need a mask with 4 ones in it. That is 0, 0, 0, 0, 1, 1, 1, 1. How do we generate this mask? We use a neat trick. Shift 1 left by k positions, then subtract 1. 1 shifted k times will give you this result. After subtracting it by 1, this is the final mask that we obtain. Now we have exactly k ones. Finally, we apply the mask using AND operation. So, when you AND the shifted data with the mask, we obtain our final result. This removes all unwanted bits and keeps only the required range. Let's see if this code has any errors. No errors, so we'll go ahead with the debugging. Okay. Area is the assembler directive which defines a section of memory. Extract is a name given to that section of memory, and that section of memory is defined to store this information. Since the information is nothing but an instruction, we have code written here. Read only indicates that this section of memory should not be manipulated during runtime. Entry indicates where exactly execution starts. That is, the very first label is the location where execution will start. Let's see what's happening here step by step. At first we have a LDR, that is load instruction, which will store this 32-bit data into register R0. Let's see that happening. Now let us load value of m, that is the start bit, into R1 and end bit into R2. In this instruction, our desired shift right operation will happen by 4-bit position. So what should happen with the data? The last digit should be discarded. Let's see that happening. Now we are performing subtraction of R2 and R1. Result is 3. So that should be stored here, followed by an addition. So the final bit width, that is 4, is stored in the register R4. R5 is loaded with the value 1, followed by that R5 is left shifted by 4-bit positions because R4 is stored with the value 4. And finally, we are subtracting R5 by 1 so that we get our desired mask. Okay? And now we are performing our final AND operation. And the result of the AND operation is 3 because the bits we have extracted between the bit position 4 and 7 represent the number 3. Stop B stop is an infinite loop, and end is nothing but the assembler directive which indicates the end of source file. That's all about this code.